Hello, and welcome to the fourth and final part of what I've learnt so far about event sourcing in a microservices environment. As we've said in the previous video, the presentation is most suitable for developers with design experience, particularly in microservice environments. And we've created this presentation because when I started looking into communication between microservices and event sourcing, I found a lot of contradictory information and differing opinions. So this is a distillation of everything I've learnt from sources that I came to trust and subsequently put into practice to prove that it works. The previous videos in the series cover the foundational principles of CQRS event sourcing and a typical architecture. This 7-minute video applies what we've learnt to a practical situation and includes a note on choreography versus orchestration. So let's take a look at event sourcing and microservices communication in practice. To demonstrate the principles, I considered the business domain of a distribution company and the types of interactions that might happen between different departments or bounded contexts in the real world. I modelled what would happen when an order is being completed, and to keep things simple, I only considered the order and the product departments. The completed order would be reported to other interested parties as a domain event, containing all the required information. Okay, so let's take a look at the architecture. So we have the order service and the product service, and an extra service in the middle. The order complete process orchestrator implements a saga pattern and is responsible for taking a completed order through the business process by interacting with other services. So as we've added an orchestrator, it's probably worth mentioning the differences between orchestration and choreography. Orchestration is where individual services are controlled by a central orchestrator. For example, the violins play when the conductor tells them to. The benefit is that it's easier to maintain the business process, as it's defined in one place. However, it's at the expense of encouraging dependencies between services. Choreography, on the other hand, is where individual services respond to events and messages independently, like dancers respond to the beat of the music. Now there is no dependency on a central controller, and no single point of failure, but because the business logic is now distributed between different services, understanding the business logic can become quite complex. Both approaches are valid in the right context. For example, if I watch a video on a video streaming provider, various services might be interested in that information, such as popularity services or recommendation services, but they are independent of a central business process, and so much more suited to choreography. Whereas in the order processing example, the order processing logic is defined business logic that may be liable to change frequently. So it is important that it is easy to understand and change, hence I decided to go for orchestration rather than choreography. The product service only cares about the types of products and how many are available and how many are reserved, whereas the order service cares about how an order got to be in its current state. That's to say, the events that led to the current state, such as who added an item to an order and at what time and what price it was added to the order. Therefore, I applied event sourcing to the order service. One of the biggest mistakes made with event sourcing is to have a central event store for the entire system where all services can read and act on events. But domain events are not the same as event sourcing events. For example, when an order is finalized, only at that point should we reserve credit in stock. As such, a domain event may carry additional information, such as the order cost and the products on the order, whereas event sourcing events adjust the incremental differences after each command. If product is only reserved for an order when the order is completed, in a world where the product service had access to the order event stream, because the event to say the order is finalized would only contain the fact the order is finalized and not all the product information, must the product service track each event that adds product to an order in case that order becomes finalized. What happens if the order is cancelled? The product service logic would become too complicated if it were to act on the internal events of the order service. Acting on those is solely the responsibility of the order service. It is much simpler and closer to reality for the product service to only care about an order when it's required to do something to the stock. So an order completed domain event is required, which contains all the required information. The events and event sourcing effectively form the services database, and we already know that allowing other services access to your database causes huge problems in terms of coupling. So event sourcing should be confined to a service, much like a database would be. When a product is added to the order service queries the product service to ensure that product exists. If it does exist, an internal event is raised. If it does not exist, an internal event is raised, which causes the order to not be able to complete. But if no response is received, no event is generated, and the order cannot complete until that appropriate event is generated. In this instance, the call is synchronous, which may appear to go against general wisdom, as the order service becomes dependent on the product service. However, the call is just a query. We're not trying to update the product service, and the call was made with a timeout. So if the response is not received in a timely fashion, the order service continues without raising an event concerning the product's existence, and the order cannot be completed until that product's existence has been confirmed. To communicate between services, particularly where we do want a state change to be effected, we can send domain events, something that's happened in the past to the sending service. When an order is considered complete, the order service publishes an order completed domain event to the appropriate topic on the message bus. The order complete process orchestrator cares about this domain event, so it reads it from the message topic. The message bus decouples the two services. If either is unavailable, neither will be affected, nor does either service have to know about the other, just the message bus. The business process now reserves the stock. Obviously, the order complete process would have a much more complicated state machine to work through, probably with more services to orchestrate such as credit control or shipping, but for the demonstration, we can stop here. So let's end on another common question. Should you really have synchronous calls in a microservices architecture? Well, it depends on your context. Trying to satisfy all the dogma you may have learnt from different blogs and presentations can quite quickly lead to design paralysis. The aims of microservices architecture include no coupling between services to facilitate the ability to scale independently and spin up and spin down without loss or impacting the rest of the system. A synchronous call to a load balancer allows us to call services that can scale, as we're calling the load balancer, not an individual service. But we still have to know who we're calling, and if the service is down, the request will fail. Queues and topics completely decouple services because they don't have to know about each other, just the messages and events they're expecting. But this requires the most development effort. A synchronous request and response is much easier to implement than putting a request on a queue and waiting for a response on another queue and correlating those request-response IDs, not to mention the monitoring and maintenance of the messaging application, plus the compute resources that it uses. If your design can accommodate a failed synchronous request, then that might be the way to go, given the reduced development effort and reduced cost to run. And Netflix do it, and they're running quite a successful microservices architecture. When retrieving a license for watching a video that's been saved to a device, the service may make a synchronous HTTP call to the license server. If the synchronous request fails, then it's assumed the license is valid, so it fails happy, and the user has no idea. If it's sensible in your context, then it's probably the right thing to do. If you have any more questions about this or any of the videos in the series, please feel free to email me directly or get in touch with Triad via the links shown.